Okay. So sorry for stop while. Okay. So we will continue a bit. Okay. I wish to stop before the integration, but we continue the tutorial on the differentiation lah. Okay. So now just how we said about the pole. So now we have a look. For example, I have this one. I want to find the pole of this one. Okay, and then I know is what order also. So what we do is we try to merge them. Okay, because it's only one function. It's a single function. So single function which is in the division. So we try to merge this one because I don't want the plus and minus here. Can be times, can be divide, but cannot be plus or minus. So we try to merge them, and then I have this one. Now I know this one is my H, this one is my G. Okay, so what is pole? Pole is G not equal to 0. So I make this one equal to 0. That means I have Z equal to 0, Z equal to 2. So when you put inside 0 and 2 here, okay, you put 0 and 2 here, make sure it is not equal to 0. Okay, it is not equal to 0, then I know this is the pole. This is a pole, and then it depends on the power. Since Z is power of 1, so hence this is a simple pole. This is Z power of 5, hence this is a pole of order of 5. So that's what you have here. Okay, any questions? No questions, then I proceed again. Okay, this one very clear lah. This is one pole. Okay, and then sorry, this is not the pole. This one is not depend on this one. It's depend on this one. So I have two. I have one is Z equal to 0. One is Z equal to, because Z square equal to -1, so it's plus minus I. So you have to make sure you put 0 here, not 0. Okay, you put I here, also not 0. So this one is the pole. Just we don't know the order. Okay, so since this is Z squared, so I know this is a double pole of or order of 2. This is Z equal to I. Okay, Z equal to I or negative I. And this one is power of 1. Not depend on this power, but power of outside. So this one is simple pole. Okay, so same thing here. This one, okay, your Z cube plus 1 equal to 0, then you have the answer of this one. Your Z will be this one. Okay, so your Z is this one. So where the K is 0, 1, and 2 lah, because this one is power of 3, Z power of 3. So K is 0, 1, and 2. So what we do here, okay, again, you have to, of course, quite clear, you put inside here won't be 0. Okay, and then you have 3 answer, 1, 2, and 3. Okay, and then order of what? Order of 6. So hence you have 6 here. Okay, this is when you substitute your K is 0, K is 1, K is 2 lah. Okay, very simple. Okay, so if your FZ is EIZ, okay, FZ is EIZ, then okay, Z equal to 0 is an isolated essential pole. Okay, this is I think not inside. Okay. If your M is infinite, if your M is infinite, that means your GZ is power of M, something power of M. Okay, and your M is infinite, then we said okay, is isolated as essential pole. Why we said so? Okay, if you merge them together, because if you reach some point where one up to infinity factorial and then divide by times 1 Z power of infinity. So when you plus all together, okay, you have to merge them together, then will be Z infinity. Everything has to times become Z infinity. So it's until infinity. So this one is when Z equal to 0. But the order is what? The order is infinity. So hence we said this is isolated essential pole. Okay. So for lecture, we will stop here first, but we continue with our tutorial. You continue try to do the questions just now I mentioned. Maybe like 5 minutes later, we will try to do. Okay, so now we'll have a look. So I want to prove that this is by means of differentiation by first principle, so that this is entire. Okay, so uh, okay, so I want to show this one is entire. So now let's say I try to differentiate first. Okay, I want to get the limit. Okay, because I want to use a first principle. First principle, that means now I know my fz is z cube. Okay, and then I want to differentiate. Okay, I want to differentiate. That means I will have fz plus delta z minus the f delta z divided by delta z. This one should be fz, is it? I can't remember. 1 minute. Okay, so first principle said that minus fz, not this one should be minus fz. And also don't forget it should be limit of delta z approach to 0. So this one it will become limit of delta z approach of 0. Okay, f delta z plus the fz plus delta z power of 3. So this one will be z plus delta z power of 3 minus your fz, which is z cube, divided by delta z. So we try to expand it. As long as this one is differentiable every way, okay, your answer is differentiable every way, then it's entire lah. Okay, so we try to expand it. You will have z cube plus 3z square delta z plus 3 z delta z, and then plus square here plus delta z cube minus of z cube divided by delta z. So z cube and z cube cancel each other, and then everything divided by delta z. Then what I left is delta z greater than 0. What I left, it will be 3z square plus 3z delta z plus delta z square. So I put in delta z equal to 0, this one 0, this one 0. So I left the answer 3z square. 3z square is analytic everywhere, it's continuous everywhere. Okay, 3z square continuous everywhere. Hence, it is entire. Have a look. And B, I will leave it to you. Okay, now I proceed. Second questions. We want to determine which of the following functions satisfy the Cauchy-Riemann equation. Okay, so that's very simple. We try to, okay, for example, A, U is x cubed minus 3xy squared. So my ux will be 3x squared minus 3y squared. My uy will be negative 6y. And then what is my v? My v is 3x squared y minus y cubed. So what is my vx? Will be 6xy. What is my vy? 3x squared y minus 3y squared. So you will see ux is equal to vy, and then your uy is equal to a. Do I miss anything? Yes. This one I left the x, I'm so sorry. X, y. Okay, so you will see ux is equal to negative, uy is equal to negative vx. So A is fulfilled, is satisfied the Cauchy-Riemann equation. So A, yes. Okay, and then in each case, express fz and f prime z in terms of z equal to, so what we see, this one, this one, this one, this one is continuous. So we try to express the fz, okay, since ux, vy, uy, vx is continuous. It is analytic. Okay, so it is analytic. So now I can get the fz. So what is my fz? Fz will be this one. Don't want to hide it right here. Okay, so what is my fz? Again, just like just now what we said, fz will be the same, but change your x into the z. So you will have z cubed. The y becomes 0, so this one whole thing will be gone. And then plus y will be gone. So this one 0, 0, so nothing left. So only left fz is z cubed. Okay, and then how about your f prime z? Your f prime z will be ux. Okay, your ux is what? Is this one? Okay, ux is this one, and change your x into z, so you have 3x squared. Your y will be 0, and then plus I times your vx, I times your vx, but 6xy. Y, put your y equal to 0, so whole thing will be gone. So no more this part. So this one will be your answer. As a similar way, try to do the B. Okay, so I think the B and C will be the same lah. Okay, I'll do the B lah. Okay, C I don't want to do. I do the B. So I do it here. Okay, so I know that my U is sine hyperbolic 3x cos y. Okay, and then my V will be cos 3x sine y. So your ux, what will be your ux there? Your ux will be cos hyperbolic 3x cos y. And then your uy be negative of sine hyperbolic 3x sine y. Because cos to sine got negative. Huh? Okay, and then your Vx is what? Your Vx will be, alamak, I forgot the 3 here. Okay, your Vx is what? Your Vx will be 3 sine hyperbolic 3x sine y. But your Vy is what? Your Vy will be cos hyperbolic 3x cos y. So what we see, this one and this one is different. This one have 3, this one don't have 3. So ux is not equivalent to Vy. So hence not fulfill the Cauchy Riemann. Not fulfill the Cauchy Riemann, automatically not analytic. Okay, so B no need to do. C I think also the same thing. Okay, E you can try on yourself, see whether you can get or not. But basically it's the same way as A lah. Okay. So I will proceed to question 3. If you have no question, please have a look. Okay. Question 3. So I want this one satisfy Cauchy Riemann. So that means this one will be U, this one will be my B lah. So my U will be okay, I directly do the UX lah. UX will be A cos X cos hyperbolic Py. Okay, this one should be equal to your Py. So this one differential to Py, differential to Py, then I will have 2 cos X cos hyperbole y. So in order to let this one and this one to be the same, a must be equal to 2, b must be equal to 1. Just that simple. Okay, try to do the last questions for today. Okay, question 4. Okay, so I want to find the zeros. Okay, I want to find the zeros. So this one equal to 0. So Z4 equal to 16. Okay, come no. Z4 equal to 16. So your Z will be 2, is it? So Z equal to 2. Okay, Z equal to 2 is double order lah. It's double 0 lah. Okay, because it's power of 2. Actually, you should have more answer. Let me think. This one actually should have more answer. Tutorial 1, this one is tutorial 2, question 4a. The question 411. Yeah. Okay, you should have more answer. You should have plus minus 2 plus minus 2i. Okay, this one I doesn't write. Okay, so you should have okay, we have plus minus 2 and then plus minus 2i. All of this one power of 4 you get 60. Okay, so all of this one is order of 2 lah, which is double 0 lah. Double 0 or order of 2 is the same thing. Okay, and then this one z sine square I z. Okay, so that means you have this one. So that means you have two answers. One is z equal to 0 because you let this one equal to 0 lah. Huh? So you have z equal to 0 or sine square pi z equal to 0. That means your sine pi z will be 0. That means pi z equal to n pi. Sorry, what I'm writing there. Pi z is equal to n pi. So I know that my z is n is another answer. So I have two answers. One is z equal to 0. One is z equal to n. Okay. So now because this one is 2, 2 actually is same as you put the 2 outside lah. So I know this is a double pole or order of 2. Double order, sorry. Double order or order of 2. Okay. Double 0, sorry. Double 0. Simple 0. This one z equal to 0. This one, the answer is wrong. How come order of 3? Let me check. Oh, okay. Okay. Why order of 3? Because very simple. Okay, why this one is not simple order? Simple 0, but order of 3. Okay, because got 3 times. One time is when here z equal to 0, this one will get 0. When your z equal to 0 here, okay, this whole thing also will be 0. And this one is power of 2. So plus together 1, 2, 3. So this one should be order of 3. Because it's been used of 3 times. So it should be order of 3. And this one is double 0. Okay. And then this one. Okay, so this one, if I take out the EZ, then it should be 1 minus EZ. Let me see. And then I let this one equal to 0. That means this one 0, 0. This means we will have two answers. One is EZ equal to 0. Another one is EZ 1, 1. Okay, EZ equal to 0. That means this is that equal to not 0. This one is something need the knowledge of the sound. Not 0 won't give you answer. This one no answer. EZ won't give you 0. Okay. How many also won't give you 0? So this one we just ignore it. We just let it lah. That EZ never get 0. EZ never get 0. Okay, so we continue this one. This means my z will be log 1. But don't forget, log 1 is just direct. You don't just direct just like that and get 0. Log 1 like just now, because this one is a complex number. So you have to consider a complex number. So 1 is here. 1 is here. Okay. So this one is equal to log of 1 plus I times the theta. Where the theta is 0 plus 2 pi high. So that means it will be 2k high. So your z will be 2k high. Okay. So z will be 2k high, and this one is power of 4 times. This is a simple 0. Or order of 1. Okay. So you will see 2k high equals 0. Any questions? I still have a bit time. I have crossed a bit. Just know a bit what is the integration, what we will learn to do integration. If you have no questions. Okay, so I'll proceed first. This one, question 5 and so on, we don't do that. Yeah, I'll proceed to integration. Just a bit lah. Okay, so basically what you learn just now is later you will need to expression. Okay, but first, now let's see. Apart from expression, represented by the parametric of this one. Okay, later we'll see how we use this one. Okay. So for example, if z equal to t plus t squared, then you have some y equal to x. Okay. Then because if this one then the y is t squared. So when you merge them, that means x squared will be equal to y. So that's why you have this one. Okay. And then this one is if you have this one, then you will be a circle. Okay. So later you will see that. Okay. So now this is a definition of integral over the real interval. Okay. So now let's see how we're going to do it. Okay. So let's say I have a function. Okay. I have a function inside a complex plane. It will be defined by anything is because this is my function, complex function. Okay. Then the another is this one. A to B FT dt. Okay. And then is divided by utility plus IPT dt. That means I can separate the two. This one dt, this one dt. Okay. So this is this one. Okay. So this one, okay, again, line of control, I think over the curve. Okay, so let's say the axis is this one. Where your t is defined in A and B, then of F over the C is given by this one lah, and that is given by this one. So what we do here is we try to into the dt and then everything is separate by using the chain rule. Okay, if it's a simple clock, the curve is clock, then we give this one, but basically it's still this one. Okay, we try to make it to dt and then prime dt. Okay, because this is dt times the dt. Okay, so cancel each other, you still have for z. Okay, so it's in the parametric form. Okay. Normally try to make it to the parametric form is easier. Okay. So for example, I want to integrate this one. So to integrate this one, I just integrate with respect to t directly. Okay. This one, integrate with respect to t, I will have t squared. This one, integrate with respect to t, I will have t power 4 divided by 4. T power 4 divided by 4, and then put into 1, 2, and get the answer. That's like normal integration is very simple. Okay. And then you will have this one. It's the same thing lah. Okay, no matter how you do it lah. Okay, and then this one also the same thing lah. What you do, because you have you have EIT. Okay, EIT, you integrate of ET dt, you still will get the ET. But if you get EIT, then will be everything divided by I. So that's why I have divide by I. Okay, I have divide I here. And the rest is just normal. You just put inside pi and then put inside 0, you will get this one. And simplify it, you will get 6i. Okay. So I will just stop here and then we continue next week. Okay. So before I stop the class, any questions for me? Any questions for me? No questions. Okay, so as I remember, you said this class actually we want to start it earlier. Is it like 11? Is it? Okay. This one, never mind. We remind me to discuss again on next month. No, we have to discuss because next Monday no class. Okay, so if possible, next Tuesday we start the class 11, so that maybe we do longer week. Okay, so that we of course we will have like 10-minute breaks in order to continue lah. Okay, so can we start our class next week 11 o'clock? Okay, so if nothing else, then see you next week lah. Yeah, something like that. 11 to 3. Again, depend on the progress lah. Okay, if progress are slow, maybe I extend it. But first we just said it's 11 to 3 lah. Okay, left the time to me lah. 11 to 3. Okay lah, maybe few breaks lah. Okay, so see you again. Thank you. Bye. Thank you.